Welcome to this Geomagic Freeform new feature video highlighting our integrated Artec scanning solution. Having access to your Artec scanner inside Freeform streamlines your production workflow and offers an intuitive interface for scan processing using Freeform's native tools. For today's demonstration, I will be using the Artec EVA, and we will be going through the entire workflow from start to finish and speaking a little bit about the various tools and options available. Let's begin. Start by going to the Mesh Tools palette, and you will notice that we have a new tool here at the end for Artec scanning. When you click it, you get a scan preview window, a settings window, and a whole bunch of tools in the dynabar. When you click preview, the scanner initiates and it will show you exactly what it's looking at. And as you can see, we're going to be scanning a running shoe for this demonstration. We have the ability to adjust texture brightness, scan speed, and we would have sensitivity if we were using the Artec Space Spider. So to begin, I'm going to be using the controls on the device itself to stop, start, and record, but those buttons are also available in the dynabar. So I'm going to start by moving my object a little bit, picking up the scanner, and once I've identified where the base is, I'm going to click Start Record. And you can see that now we are starting to build up a 3D model right in the viewport. I click Stop, and we're going to generate a proxy preview, which is how we will interact with this object in Freeform. And I'm going to rotate my model a little bit so I can scan the other side. You see that we have a distance indicator in the preview window as well as a status indicator. So right now green means preview, and when I click record it turns red. And that's 2 scans complete. Now I'm going to flip my model on its side so I can get the sole of the running shoe. Start near the toe. Work my way down to the heel. And flip it over and do one more scan. This way here I get full coverage of both sides of the running shoe as well as the sole. You saw a momentary red flash, which meant for a brief instant the scanner thought I had lost tracking, but it was able to recover. Now that my scanning is complete, I will hide my scan preview window, and I'm going to turn off show paint colors so we can see the individual scans. Now I'm going to go through and trim all of the excess data from each of the individual scans. Since they're all stacked on top of each other, I'm going to do this one at a time and turn off the ones that I do not want to interact with while I'm working. So I'm going to align my view, choose my Trim Box Select tool, and I'm going to select everything inside that base and click Cut Selected, as well as the data that's floating here off to the side. Cut Selected. The delete key on the keyboard will also perform that same operation. That looks pretty good. So now I will move to Scan Pass 2. This time I'm going to do it a little differently, where I'm going to look from above. I'm going to select my object, and I'm going to click Cut Unselected. So this removes everything that was outside of my selection, leaving me with just a little bit of data to trim. So move to the side, make a selection, and press delete. And that looks pretty good. Repeat this for all of the remaining scans. Now that I have everything cleaned up, it's time to align these. We will begin with the first scan, and I will align the second scan to the first. So I'm going to turn off my box select and enter reposition, and I'm going to rotate this model using the haptic device so it's in a position similar, or at least a similar orientation to the other model, because I'm going to use the point alignment tool in order to identify common regions between the two and use that as my reference for alignment. As we can see, we have common areas here, so we can see that and that on the model. We have a similar area here on the tongue, and we have one here on the toe of the shoe. So now I'm going to activate my reference model. So scan point 1 is here, scan point 2 is right here, and scan point 3 is right here. So I will select my piece that I'm going to move and click apply. Not a bad rough registration, but this will be refined a little later when we run global registration. So I'm going to clear all of my points and leave the point tool. And for the remaining two scans, I'm going to manually reposition them using the reposition tool and the haptic device. So I can visually line this up and hold shift for fine control. Rotate the model and align the final piece. And now I will activate the first scan, which is going to be the reference for which all others are going to be registered to. Select everything and click Global Registration. As you can see, that did a much better job than I did by hand, because it's using the internal structure of the actual data and the texture information in order to find similar regions and combine, or at least orient the pieces together. Now I'm going to clean up some of this surface noise. With the same selection, I'm going to show object removal, or outlier removal. Go with the default parameters because it's not a very noisy surface, but it is a bit noisy. And I am going to be working at a 1mm resolution for this model for the demonstration, whereas if I were to do this for a production piece, I might set this a little lower to capture more detail. But I will click Outlier Removal and let it process. As you can see, that did a fantastic job of cleaning up the surface. And since these are all still individual scans, we need to combine all of these into a single mesh model. So I select them all again, hide outlier removal, and show my merge settings. I want a sharp type for my merge in order to capture some of the detail around the sole of the shoe, around the toe, and even some of the laces. 1mm is going to be fantastic for this demonstration purpose to show you what this is capable of, as well as keep the demonstration moving quickly. And I do want to fill holes underneath a radius of 5mm. So with my selection made, I click Merge. Now that this piece has been created, it shows up in the object list inside Freeform as an Artec scan merged mesh, or a mesh merged object. So I'm going to hide all of my original scans. We don't need to go back to those. At this point, you could export this as an STL, you could incorporate this into your design, convert this to clay, do whatever you like with it. But Artec offers some more options for mesh processing that we can take advantage of. For instance, if you wanted to simplify this model, because right now it does have a pretty good amount of resolution to it, so the amount of polygons and faces on this model. We can run mesh simplification and choose the accuracy method it will analyze the model and give you a result that is very close to the original surface while reducing the count of faces down dramatically. This would be done for 3D printing or for aiding in the texturing, because the more faces you have, the longer it takes to texture. So I will click Simplify and let this process. As you can see, the model does not look very different from the full resolution model that we had a moment ago. And this will dramatically cut down on the amount of time it takes to apply a full color photographic texture to it, which is the final step I'm going to show during this workflow. So I will show my texture settings. A 4K by 4K resolution image will give us fantastic results, and the texture type of Atlas is the default, and it's what we want to go with. So I go to my color texture merge tool, click this, and let it process. Right now it's finalizing the piece. And we should have, there we go, a beautiful full color textured object inside Freeform. From here, we have the ability to convert this to clay, use this in any number of operations inside Freeform. We could export this as an OBJ file and keep the UV maps and the full resolution texture with it if you wanted to bring that for 3D printing or use elsewhere. And we also have the ability to save the Artec project data, which is simply all of the individual scan files. So if you wanted to revisit this project, if you wanted to rebuild this and export it at higher resolution instead of processing it down the way that we had during this demonstration, all of that flexibility is available to you. I hope you've enjoyed this demonstration. Thank you very much.